Question number 6 is very good question for the NEET point of view. So you will see very carefully. A spring force constant K connected with the center of the disk of mass m radius r. System is placed on horizontal surface and other end of spring is fixed with a vertical wall. If there is sufficient friction for pure rolling, then time period of oscillation of the disk will be. So we are looking to find the time period. So as I said earlier, if I get the value of omega, then you will be able to find the value of time period. So now this time I am going to use the energy method, because you know the mechanical energy of the system will remain constant. So first I will write the mechanical energy. First, mechanical energy in terms of half kx square for the spring, and linear or translatory kinetic energy half mb square. Because in this diagram you can analyze, if I say x is the elongation, and because mass and radius are given and the direction of angular velocity omega is like that. So when you will calculate half mb square plus there will be rotational kinetic energy for the disk half I omega square, and as I said that is equal to constant I am going to suppose by c. Now half kx square plus half mb square. If I place the value of I, because you know the moment of inertia of the disk about geometrical axis is 1 by 2 mr square by 2 will be the moment of inertia of the disk, as I said. And omega in the case of pure rolling you can replace by v square by r square, that is equal to c. So r square will cancel out. You have 1 by 4 mb square. When you will add with half mb square, then you will get half kx square 3 by 4 mv square, that is equal constant c. Now this is the mechanical energy. If I differentiate, then you will get equation in terms of acceleration. And why we are doing this? Because I need the value of omega. So I am going to take this. If I differentiate this equation, so with respect to the t, we will get 1 by 2. You know, when you will differentiate x square, you will get 2x and dx over dt, right? So 2x, and you know dx over dt is equal to the velocity, so you will write v. Similarly, k 3 by 4 mb square, mass is constant, so you will differentiate v square. First you will get 2v, and when you will differentiate v, will write dv over dt, that will give you the acceleration. So 2va. This is the part of differentiation of v square, but you know 3 by 4 was there, so you will write here, and that is equal 0. So final expression you will get 3 by 2 ma from this side, because 2 2 4 and plus 2 will cancel out, so you have only kx, and v का क्या हुआ, v हम लोग कॉमन लेंगे और वो 0 की साइड जाके फिनिश हो जाएगा, तो kx is equal to 0. Now अब we'll write a plus, if I take 2 as a LCM, then 2k upon 3m into x is equal to 0, because I am looking to find the equation in terms of acceleration. So easily you will write a is equal to minus 2k upon 3m into x. And when you will compare this equation by minus omega square x, suppose this is one equation, this is two equation, then you can observe this is the value of omega square. So if I use this value here, so omega square will be equal to 2k upon 3m. Omega is equal to root of 2k by 3m. So that will give you the value of time period. But why and how? So you know omega is equal to 2 pi upon t. So when you will calculate the value of t, from this, you will get 2 pi root of 3m upon 2k. So this is how you can solve this question. So I would like to suggest you, in this type of question, you will use the energy method. So by this discussion, I can say my option number 3rd will be the right choice. So let's move on question number 7. In the question number 7, the differential equation representing by the particle is 16, second derivative of y plus 9y equal to 0. If particle is at mean position initially, you have to be very careful this point. The time taken by the particle to reach half of its amplitude first time will be, you know, the time taken by the particle to reach half of its amplitude in terms of time period, we know t upon 12 seconds. You know, but I need the value of t. Capital T means time period, so this is our problem. So how we will calculate? You know this equation, 16. I can write this is second derivative, so that will be just equal to acceleration, and 9y you will write like that, 9y. So A is equal to minus 9 upon 16y. This is equation number 1, and you can compare A is equal to minus omega square by, this is the general equation, because I need the value of omega once again. So without any hesitation, you will write omega is equal to root of 9 upon 16, because this is the value of omega square. So you will get 3 upon 4, and this is the value of omega. So by this value, I can calculate the value of t. So you know omega is equal to 2 pi upon t, because you know the value of omega 3 upon 4, 2 pi by t. So I can calculate the value of t is 2 pi into 4 by 3. So that will give you the value of time period. Means t 8 pi by 3. But I need the value of time taken by the particle to reach half of the amplitude, and that is equal t by 12 as I said. So if I use the value of capital T, 8 pi by 3 multiplied with 12. So that will give you 2 pi by 9 second. So this is the value of required time that you are looking to solve. So by this discussion, I can say my option number 4 will be the right choice. So let's move on question number 8. The force on a body execute SHM is 4 Newton when the displacement from mean position is 2 cm. If amplitude of oscillation is 10 cm, maximum kinetic energy associated with the SHM will be. So you know that the maximum kinetic energy is given by 1 by 2 Ka square, and you know the value of K, that is equal m omega square, right? But according to the problem, I have the value of Kx. Kx means the force on body in SHM, and that is 4 Newton, right? So K, the value of x. Question says the value of x is 2 centimeter displacement from mean position in terms of centimeter, but I am looking to write in terms of meter, 10 to the power minus 2. That is equal 4, so that will give you the value of spring constant K, and that will be 200 Newton per meter. So I have the value of K. So if I use this relation once again, 1 by 2, the value of K is 200, and I need the value of amplitude, and that is 10 centimeter. Amplitude was given. So we'll write in terms of meter, 10 into 10 to the power minus 2 whole square. So when you will calculate, we'll get 1 joule only. So by this calculation, I can say my option number 1 will be the right choice first. So let's move on question number 9. In the problem number 9, The time period of simple pendulum inside a stationary lift is t. Lift start accelerating upward with the acceleration of this, then new time period of the simple pendulum. Before going to calculate, you know very well when lift is going up with acceleration, then final acceleration will be g plus a. If lift is accelerated downward, then acceleration will be g minus a. So this fact I will use. The time period at stationary lift is given by 2 pi length and effective acceleration due to gravity. So as per the situation, t1 2 pi length will remain same, but effective acceleration will be g plus a. So g, but the value of a as per the question was g by 2. So I will write here. Simply you can calculate on solving 2 by 3 L by g. Now, but the answer is given in terms of t. So t is equal to 2 pi L by g in the situation. So first I will write t1 is equal to 2 pi root of 2 by 3 L by g. So root 2 by 3 will be the external part. So I can write like that 2 by 3, and in place of 2 pi root L by g you will write only t. So the final answer will be root 2 by 3 into capital T. Right? So my option number 2 will be the right choice. So let's move on question number 10. In the question number 10, the displacement equation of travelling wave pulse is given by this, where xy in meter is speed and direction of propagation of the wave pulse is. We know d over dt in terms of position of time ax plus minus bt will be equal to 0. And where if I differentiate, then you know dx over dt will come, and that is called speed of wave propagation. So if I concentrate on this, then because I am looking to make the given expression just like this. So 10 x square, and this is 6 square, and this is 2 into 6 into x into t. So I can write this is x plus 6t whole of square. So when you will concentrate in this expression, x square 12xt and 36t square plus 25. So I can write x plus 6t with whole of square plus 25. So you know you will concentrate on this only, just like. So I will write here d over dt x plus 6t only, and that is equal 0, right? So when you will differentiate dx over dt plus 6 dt over dt, that is 0. So t over t is equal to 1, and this is the speed. So v is equal to minus 6, and this minus sign will indicate the propagation of wave along negative x-axis. So by this calculation I can say my option number 2 will be the right choice, 6 meter per second along negative x-axis. So let's move on question number 11.